Hello everyone, I'm Gerard. I've arrived at virtual reality through architecture, but I won't bore you too much with that story. But what virtual reality is, it's the real-time simulation and interaction through multiple sensory channels. So basically reality. And it's to immerse yourself in a world of your own construction or design. But really, what is virtual reality? So current commercial immersive virtual reality relies on no contact with the outside world. You're fully immersed in your own world, and the possibility to hit someone or something is very probable. But we're all very familiar with one or other virtual reality. This is Windows on World. In your PC, there's also a kind of virtual reality. Today, we're also dealing with Telepresence, and there's a lot of interesting developments here. So flying your drone without actually flying your drone. There's also a lot of very scary developments here. Flying your drone without having to fly your drone. Robotics as well, very interesting what we can do. Go to Mars with an extreme amount of lag, perhaps. And then mixed reality, which is where the excitement really lies. And this is what the future will be like. So, and what that's about is it's the seamless integration of real and virtual reality. And it's about experiencing natural presence of 3D objects and information in the real world. And this is perhaps very exciting because we can drop monitors altogether and we can have a lot more social type of computing interaction. And then there's distributed virtual reality, which is the internet and the power of the cloud. So where did all of these come from? It hasn't changed much. This is what my studio looks like now, and this is a very old picture. But it's a type of person, I think, that works in virtual reality. But it started way before that. It actually started in 1838 with stereoscopic photos and viewers in geography books. And then in the 20th century, we had flight simulators. In 1988, we had the commercial development. Starting in 91, virtuality, which was one of the first commercial or available headsets. Interesting to note is the difference between the 1950s headsets and 1991. Obviously, the military has a lot more finance and funding available. Interesting also is in 2012, and then this sort of augmented reality experiments, which came from the CAVE automatic virtual environment, which is just projections on a room, and your motion tracking gives you your position in that room. But yes, so today we're in a new era of virtual reality where cost and performance ratio is almost perfect. It's accessible, and the development platforms are easy, and I think that's the most important thing, is anyone who walks out of school can now develop for virtual reality. But it hasn't changed much, and the rules for it haven't changed much. And what it basically comes down to, and why it's important today, is because we're at this point where the synergy of hardware and software allows for this processing to occur. So real-time applications with higher experiences in graphical fidelity and new exciting ways to interact can occur. But what it comes down to is you've got your input that needs to be simulated, and you've got your output. And this is all based on your 3D world, which is what you're creating. So your input, very important, but it's your position, your orientation, and your 3D data. So these are some of my initial experiments back at university where I was trying to play with what was then augmented reality. And we didn't have screens to see through or strap to your face, but that's a tracker and a camera that I eventually attached to a construction helmet so that you could get your point of view from this. So I realized at a later point I'd actually been experimenting in this field for quite a while. But at first, a lot of these sort of experiments were in locomotion and in basic movement tracking, like hand and finger tracking. This is because this is actually what virtual reality has brought to us. It's motion tracking. So being able to track your arms and being able to have a full motion capturing studio in every indie game studio in the world right now, it's going to change how animations work in computer games. It's going to change a lot of things. But sensors are important because the typewriter was invented in the 1860s and the mouse in the 1960s, and we still use these devices today. Very important device to come along is the game controller, which came along with earlier systems, and the Wiimote, which we all might not know because the Wii was a flop in South Africa, but the controller changed the way people thought of motion controllers. It brought it into the home. And then we have simulation processing. So recent years have allowed PCs to process a huge amount of data, and in real time. So where in gaming, it's all about optimization. So optimizing your 3D world to be fast. In architecture, it's all about detail. And we finally arrived in 2011 at a point where software for real-time architecture was released into the wild. These tools, Lumion and Twinmotion, made ArcViz much easier for an architect. These programs also adopted techniques from gaming engines like lighting, reflection, water, and vegetation. And they were real-time what you see is what you get environments, which are very important for architects to experience space. But it's also a lot of this. So this is a very basic example of code, or coding for 3D. But we're shooting a laser, we're hitting something, and we're putting something where we hit that laser. So there's a lot of talking to the computer, and there's a lot of intricate instruction, a lot of logic. And then all of these things are done by extremely powerful PCs. In the past, it used to be supercomputers, but now it's just a computer under your desk. And these have to run the simulation. So we go from input to simulation, and then to rendering output. So these are images, videos, and now virtual reality worlds. The rise of the head-mounted display has finally led to a better way to experience these spaces, because it's one-to-one, and you can finally truly feel space as it was meant to. The other thing is to match these inputs with your output and fast, so that your hand isn't lagging behind where you're looking or where you're trying to build 3D spaces. This is an experiment where I was trying to figure out how to record myself in virtual reality, how to make things in virtual reality, and how user interfaces might work in virtual reality. So today we actually have quite a lot of options. We have VR, so you can buy the Oculus Rift. I think you can buy them in South Africa now. The HTC VIVE. Then you've got the Daydream, which is a mobile headset. But you've also got mixed reality headsets. That's the Hololens. That's the device I was wearing in my GIF. That's extremely interesting. That's the entire computer on your head. So there's no other computer involved. You literally walk through space, and it's analyzing the room in real time, and you can project your data onto that in real time. But what does this all mean for games and interactive design? Patents. Lots and lots of patents. It also makes it very difficult to do things because you're too scared to do something in case someone else does it better. It's a very fresh and interesting industry, so we're all trying to find our feet. But what it does mean is that we'll experience presence in virtual environments and interactive environments where you could swing. In your own children's book, I remember my parents, and they're here, but they made a book for me when I was younger. And this is what we'll be able to do. We'll be able to tell the story exactly how we imagine it spatially. And as soon as you add headphones and some other sensors, you can actually recreate sensory experience. Well, with positional tracking, it means you can walk through space. And with these mixed reality headsets, you can literally walk through a site. So in architecture, for us, this is important because we can walk through a construction site and overlay the design of the construction to see whether or not you're on the right track. For education, obviously, it's very important because we can bring worlds to people who will never be able to experience them. We'll also be able to train people with things that we've also never been able to take people to. As soon as you add the correct sensors and tracking, you have controllers and boundaries, which means that with the correct application of all these senses, you can explore pretty much anything. If you have a fear of heights, you might be able to get over it with some post-traumatic stress disorder treatment. And they're already doing this in VR. Once you've done that, you could fly. So, flight and unique applications are also on their way. This is a very interesting, this is the Oculus, the first developer's kit. This thing doesn't even know where you are in space. So, very interesting experiment, and it started a while ago. And then with augmented reality and mixed reality, it will offer even greater and almost impossible and moving experiences. For us in architecture, it's fantastic because we're able to visualize large and complex data without having to pre-communicate design. So we see that a lot. Clients and architects enter the same space, and they haven't yet discussed the concept, and they can already sell the feeling of the space. It's quite important in today's day and age where it's all about data, so we're constantly prepping new documentation all the time, and with tools like this, you don't need to. It's all about communication, and there's an immediate understanding with these tools. This new way to interact with computers are going to mean sculptors and musicians and many other skill sets are going to get extremely interesting tools. So this is the initial version of Oculus Medium, which has just been released, and it's a 3D modeling tool for artists. People are actually doing production-ready stuff with this, and it takes minutes instead of days to produce very interesting three-dimensional explorations. And also very soon, this will be a reality, where we'll be able to design in our spaces that we're used to, and not on the canvas of Photoshop. What's more exciting is a new generation of physicists and digital strategists. Educational games will come around, and it will bring places and experiences to people. Training in industries, so hands-on experiences based off other people's previous experiences. And then gamified tools in industries and enterprise, which will make work exciting and easier to use. So we've recently started experimenting in this space as Tenebris Lab. It's a CG-based VR mixed reality software development studio. This is a video, I think some people in the audience have actually played this, but of the first game we're making. Camping in virtual reality. So I don't have much time for the outside right now, so I had to recreate it for myself. It's a little sad, but it meant I could experiment a lot with interacting in virtual reality and figuring out how a lot of these tools and experiences work. But yes, it's a survival horror game for wussies, because I don't like the dark either. Great. Any questions?